question C then. Same method as before. Let's look if we can spot any properties. In the left-hand side, we've got A union B complement. So we've got to deal with that bracket first to get rid of this little complement sign. We can see that that is De Morgan's law. So we're now going to convert that into A union. And what we get then is A complement intersection B complement using De Morgan's law. What about the right hand side then? We've got a similar situation. We've got another union, the complement of a union here. So again, we're looking at the same De Morgan's law, this one, except that we've, instead of A and B, we've got A complement union B. So let's just write in, what do we have here? B union, so B union. Now, in De Morgan's law, we apply the complement to both of these. So A complement complement just becomes A. We swap the sign around, and B becomes B complement. Super. And now we look, are there more properties we can apply? Or is there any simplification we can do? Okay, so the right-hand side, doesn't look like there's anything obvious we can simplify. So, sorry, the left-hand side. Does this look like any property in that table? Well, if you go through, no. Distributive, yeah, it looks like the distributive, doesn't it? It's actually looks like the left-hand side of this. So we're going to use the distributive now. So instead of A union B intersection C, we've got A union A complement B complement. So let's just write that out, and that turns into A union A complement intersection A union B complement. We leave it like that. And then we look on the right hand side. What have we got on the right hand side? Well, we've got B union, so the union of an intersection. And that's exactly the same property we've just used. It's this distributive property here. And in this case, we'll end up with B union A intersection, which comes from here, B union B complement. There we go. And now hopefully we'll be able to simplify some things. A union A complement, I think that's clearly going to be the universal set, and where it intersects with A union B complement. And then on the right hand side, B union A doesn't simplify. B union B complement, yes, does simplify. Again, it's the universal set. So we've got, there we go. And now let's see if we can simplify further, because here the universal set intersection with all of this, A union B complement, is just A union B complement. There we go. Similarly, on the right hand side, B union A intersection with the universal set is just B union A. And then we say, right, we're nearly there. What does this now look like? We've got the intersection of two unions. So let's go up. Which one does that look like? It's the same property we've used a couple of times already. We're looking at this, aren't we? The right-hand side of that distributive property. Before we simplify this, then it might be easier to switch this around. Instead of B union A, we can say that that's the same as A union B. And then if we convert this into the left-hand side of that distributive property, we get A union B complement intersection B. Let's just check that that works. A union B complement comes from applying the union here. A union B comes from applying the complement here. And they're separated by an intersection. So yeah, that's fine. Now we've used that property. Can we simplify that further? Well, B complement intersection with B, what is that? Any guesses? They have no intersection, so that would be the empty set. So we've got A's union with the empty set, so everything that's in A and everything that's in the empty set, and that of course would be A.